Hello, viewers. In today's session, we are going to discuss an important problem from limits. So, here we are going to evaluate this limit extends to 0, and here we have 1 plus x square plus 5x raised to 1 over sine x. Right, so let us see how easily we can find out the value of this limit, which is of this form, that is 1 raised to infinity, which is an indeterminate form, right? So let us first see the general form here. Suppose we have a limit of this form, that is limit x tends to a, and here we have a function, say f of x raised to g of x, right? So whenever we have a limit of this form, let us call the value of this limit as L. And if we have the condition, that is limit x tends to a, f of x is equal to 1 or it tends to 1, uh, and here we have limit x tends to a, g of x, it tends to infinity, right? So when we have a limit of this form and we have the condition, that is limit x tends to a, f of x tends to 1, and limit x tends to a, g of x tends to infinity, that is this limit, it tends to this form, that is 1 raised to infinity when x tends to a, then the value of this type of limit can be obtained by this result, that is this limit L is equal to e raised to limit, we have x tends to a, and then we can write here g of x times f of x minus 1, right? So when this limit, we have to calculate the value of this limit, provided we have this limit tending to 1, this limit tending to infinity, then the value of this limit L can be obtained by this expression. So now let us compare this limit with this one, and let us call the value of this limit as L. Now here we have limit x tends to 0, and here we have limit x tends to a. So the value of a is equal to 0, and f of x is given by this quadratic polynomial, that is 1 plus x square plus 5x, and g of x is given by 1 over sine x, right? So let us first see whether these two conditions are satisfied by these two functions, f of x and g of x, when x tends to a, that is when x tends to 0, right? So here we have a limit x tends to 0, and for f of x we have 1 plus x square plus 5x, and we can easily see that the limit of this quadratic expression when x tends to 0 is 1, right? So we have 1 plus 0 square plus 5 times 0, that is simply 1. So this limit, that is limit x tends to 0, f of x is equal to 1 or it tends to 1. And similarly here we can see that we have limit x tends to 0, and for g of x we have 1 over sine x, right? So when x tends to 0, then sine x tends to sine 0, that is 0, right? So we have this expression, that is when x tends to 0, 1 over sine x, it tends to 1 over 0, and this expression tends to not defined, that is infinity, right? So here f of x and g of x satisfies these two conditions. So now the value of this limit can be obtained by using this result, that is L is equal to exponential, that is e raised to limit x tends to a, g of x times f of x minus 1. So we can now write L is equal to e raised to limit, and we have x tends to 0. And for g of x, we can now write 1 over sine x, and f of x is 1 plus x square plus 5x, and here we have minus 1. So now we can simplify it. E raised to limit x tends to 0, and here this one and this one get cancelled, and we have x square plus 5x divided by sine x. So now we have to evaluate this limit, that is limit x tends to 0, x square plus 5x divided by sine x. So now to get the value of this limit, we can here apply L'Hopital's rule, but we'll simply use the algebraic treatment. We can take x common in the numerator. So we have here x times x plus 5 divided by sine x, right? And in the next step, we can take this x to the denominator of sine x. So we have simply x plus 5 divided by sine x divided by x, right? So now we have this expression, and the limit L can now be given as e raised to limit. We have x tends to 0. First we have x plus 5, and then in the uh, denominator we have limit x tends to 0, and we have sine x over x, right? So now we can write here in the numerator limit x tends to 0, x plus 5. So we have 0 plus 5, and here in the denominator the value of this limit is equal to 1, because we know that limit theta tends to 0, sine theta over theta is equal to 1. So this is a standard result in limits, right? So we have e raised to 0 plus 5 is 5, 5 over 1, that is e raised to 5. So the value of this limit is equal to e raised to 5.